Yay, welcome back. So this is a continuation video. We are going to revisit the bathroom door coat hook design. Last video we did it in Fusion 360. You can find it in the link below. In this one we're going to do it in Autodesk Inventor. So to refresh your memory, this is the design. It's a simple aluminium body with a rubber stop on the end. There are two countersunk holes and another threaded hole that you can't see here for fixing on the hook. So let's get to it. Here we've got the completed design already in Inventor. So we've got two parts. We've got the aluminium body and we've got the rubber stop on the end. Now to design this is going to be fairly straightforward. So and we're going to take a bottom-up approach. That is to say we're going to create one part, then another part, and then put them together into an assembly. So let's get to it. I'll go and click File, and we'll click New. And here we'll click standard millimeter.ipt and click Create. We'll get started by creating a 2D sketch on the XY plane. So to create a sketch, we'll come to the top left and click 2D sketch. And then we'll click the XY plane here. Great. Now we're going to draw a few lines with dimensions. So we'll click a line, mouse over the origin, click, and drag it outwards. And this first line here is going to be 60 millimeters. So we'll type in 60 and hit enter. If you hit escape, you'll find that you can click and drag the dimension. Next, what we'll do is we'll create a line that will come from the origin and come down 40 millimeters. Great. And hit escape as before. Next, we want to capture the little hook at the bottom. So we'll come along and we'll click Arc, and we're going to draw a 3-point arc. We'll click at the end of that line there, another point in space arbitrarily here, and then a third arbitrary point here. If you're eagle-eyed, you notice that you can create the tangential constraint automatically, but we'll do it explicitly. So go ahead and just click randomly there. So we want this arc to be tangential to this vertical line here. To achieve this, we'll add in a constraint. So we'll come to the constraint panel here and click the tangential constraint. We'll click the vertical line there and the arc. And then next we'll hit escape. So now we want to define the size and the termination angle of this arc. So to define the termination angle, we'll go ahead and we'll draw a line from the origin of the arc to the end of the arc there. And hit escape. Now, because this line is not really a line that we're going to use for creating a profile, what we'll do is we'll select it and we'll make a construction. So there's two ways of doing this. You can select the line and click up here and click the construction button. Or alternatively, you can right click the line and come to the right here and click construction. Great. So why do we draw a vertical, a straight line like that? It helps us to define the angle of this arc. So we'll go ahead and we're going to add in a dimension. So we'll say dimension, or D as the shortcut. And we'll draw an angle between that line there and this line here. And it will be 52 degrees. Great. Next, we'll define the size of the arc by adding in a dimension and clicking its outer rim. And we'll click down there and click 22 millimeters. Good stuff. All right, next we'll hit escape. And we'll draw a final line up here at the end, and it will come up 14 millimeters. Now, because we're lazy, we are going to use the offset approach to make this a profile. So go ahead and click offset, and we'll choose this chain of lines. And if we click it and if we drag it outwards or inwards, we get an almost closed profile. So go ahead and we'll drag it inwards, and we'll type in 4 millimeters and click enter. Now, it's done something that's undesirable here, but it'll be an opportunity to learn. The first thing that we'll do is we will close off this top line here, or this top gap here. There we go. And now here, we are going to make this line construction. So go ahead, select it, right click, and click construction. And now we want to close off this hook in a nice way. So we need to extend this arc to this line here. To do that, we'll come along to Extend, and then hover over the line of the arc, and you'll find that in purple you'll see a little preview, and it will extend the arc to that distance. And lastly, we'll close it off using a line. There to there. Now, if you're pedantic like me, you'll find that it's purple, which means it's not fully constrained. I noticed that it's not tangentially aligned there. So we'll go ahead and we'll add in a tangential constraint. So we'll say tangent, click this line here, and this arc here. And now we see it's all black, it's fully constrained. And we can delete this line. Great. Okay, so next we'll go ahead and click Finish Sketch. And we will extrude this out into the third dimension. So we'll click Extrude. Because it's the only profile that we've got, it will automatically pick up on it. And now we can use the golden arrow to click and drag it out. So it's 12 millimeters long, not wide, I should say. So we'll say 12 millimeters, and we'll click OK. Next, what we want to do is we want to put 2 countersunk holes here, and 1 threaded hole here. So to create these holes, we need to create points on these surfaces. So let's go ahead and we'll say Start 2D Sketch, and we'll create a sketch on this surface here. And we'll go ahead and we'll draw 2 lines, one from the middle there, and we'll come down 10 millimeters, and the other from this edge here and up 10 millimeters. You don't need to do this, but just for a matter of practice, we can actually draw the points by clicking Point and selecting the end of the lines. I say it's not strictly necessary because it's possible to select the end of the line when placing a hole. We'll go ahead and click Finish Sketch. And next we'll come to click Hole. Yeah! And now we've got the whole dialog. It automatically picks up on any points that you've placed down. So it's automatically picked up on those points. But just in case it didn't, you can select the positions, select it here, and then select the points manually. Next, we want to make sure that it's a simple hole, and that it is countersunk. And the dimensions are going to be 5 millimeter bore, and the countersink is going to be 8 millimeters. Its termination might be an arbitrary distance here, but good practice means that we'll say go to, and we'll say go to that surface. That means that no matter how thick we make this, the hole will go all the way to the end. Here we go, and we'll click OK. And now we've got our 2 countersunk holes. Good stuff. We're going to repeat the process for the threaded hole up here. We'll go ahead and we'll create 2D Sketch, and we'll create a sketch on the surface. And a bit of a cheat to getting a point in the middle of a surface, you can click and create a diagonal line that happens to connect 2 of its corners. And then you can create a point in the middle there. Good stuff. Next, click Finish Sketch. And we'll say Hole. And this time it's picked up on 2, so we actually want to explicitly define which points are being selected. We'll choose the position manually by clicking that point in the middle there. This time it's a tapped hole, and it has no seat, and we're going to make it an isometric M5. So for type, we'll choose isometric profile. For the size, 5 millimeters, M5 by 0.8. And for the threading, we'll choose full depth. There we go. For its termination, we'll select a rear surface here. There we are. And we'll click OK. And now we have a threaded hole. Good. Okay, so the last thing to do on this is to get rid of the sharp edges so that no one hurts themselves. So we'll go ahead and add in 2 sets of fillets. The first set, we'll choose these edges here. 3, 4, 5, 6, 7, 8. Cool. And we'll say that is a 1 millimeter fillet. Good stuff. The second set of fillets, we'll say fillet again, and it'll just be for edge breaking, and it'll be around these 2. So we'll say 0.25 millimeters. Good stuff. Cool. So we have our geometry. Before we save and close it, we're going to go ahead and we're going to assign it a material. So we'll come up to next to the silver ball up top, And we'll come along and we will choose aluminium 6061. So here we go. Aluminium 6061. And you'll find the color changes. Good stuff. Okay, so let's go ahead and save that. We'll hit the little diskette. And we'll go and we're going to call this bathroom door coat hook body. Next, we'll make the little rubber stop on the end. So we'll go and click again, File, New, and click Standard Millimeter. And now we're going to create a sketch on the XY plane. Okay, what we want to do is draw a profile which will be swept around an axis, rotated around an axis. So to do that, we'll go ahead and we'll create a line. And I like to draw the axis of rotation first. So we'll draw a 8mm line that goes horizontally. This is going to represent the axis around which it's rotated. Now, we want to draw half of that profile. So we'll go ahead and click line again. And I know that it's a 12mm diameter at the base. So we'll say 12 divided by 2, which will make it 6. Its end, it's slightly conical. So it happens to it's 11mm diameter at the end. So we'll say 11 over 2. And we'll click OK. And then we'll close off the profile with a line. Now, this is actually screwed in place. So we actually need to draw in a little hole and a little seat to capture the head of the screw. So to do that, we'll come along here and we'll say line. And I'll draw an arbitrary set of lines. 1, 2, 3, 4. And the first one here, this is going to be the hole through which the threaded screw is going to go through. So we'll go ahead and add in a dimension. And I know that it's going to be 4.5mm wide. So I'm going to say 4.5 over 2. And for the seat, a 1mm seat should be sufficient. So we'll say 1. And lastly, the position. Here we can set how deep the seat is. I'm going to say, let's go and make it perfectly halfway through. We can do this in a number of ways. We could add in a dimension here that says 4. Or alternatively, we could come along and say, vertically constrain this point here with this midpoint. And that means that no matter how long we make this, it'll always be halfway through. Good stuff. Okay, so we'll click Finish Sketch. And let's go ahead and revolve this. So we'll click Revolve, click this profile, click the axis of rotation, and click OK. Next, we'll go and add in the fillets. So 1, 2, 3, and 4 fillets, except they're gigantic. And we'll make them tiny. We'll say 0.25mm. Looks good. Okay. And before we go, we'll set the material. So let's go ahead and set it to rubber. Looks good. And we'll hit save. And we'll call it bathroom door coat hook stop. The last thing that we'll do is we are going to make it the assembly. So we'll go and click File, New, Assembly, Standard Millimeter.iam. Remember that IAM files are assemblies in Inventor. And we'll click Place. And here we can place the body and the stop. We'll do it one at a time because I'll show you a trick. We'll go ahead and click the body first. And I want to place it into the assembly grounded at the origin. And because I'm lazy, I'll go ahead and click right-click, Place Grounded at Origin. Good stuff. Next, we'll go ahead and place the stop. And I'll place it down arbitrarily. And it's free to move around. We'll go ahead and we'll add in a constraint to fix it onto the end of that hole there. So we'll go ahead and say constraint. We'll pick the axis of the circle, of the barrel, and the axis of the barrel here. And click OK. And you'll find that it can move backwards and forward. Lastly, we'll go ahead and we'll constrain this surface here to this surface here by hitting constrain. And then that surface there, and clicking OK. And then, ta-da! We got the completed doorstop / hook assembly done in Inventor. Okay, so I know that it was a super simple one to start up the year, but I hope you learned something, and I'll see you next episode. Oh, and if you want to see it done in Fusion 360, check out the other video. Okay, I'll see you next week. Bye.